Chinese scientists are close to bringing out one of those technologies that stayed way too long in the lab into reality. This is the electric plasma jet engine. Now, everyone knows how problematic fossil fuel engines have been for the environment, so several moves are being made by the world's brightest and most influential to reduce carbon emissions and consequently the effects of global warming. Some of these moves include the innovation of new technologies like carbon capture to remove the excess carbon dioxide in the atmosphere. Another example is the innovation of technologies that will make electric vehicles cheaper and production even cleaner, thereby eliminating the need for fossil fuel vehicles. In this video, we'll be looking at another important move, and this one is the innovation led by a team of Chinese scientists of electric plasma jet engines that will potentially replace the current fossil fuel planes in the aviation industry. Ready? Let's get started. The aviation industry's contribution to CO2 emissions. The carbon dioxide emissions from the aviation industry stand at 2% of all human-induced CO2 emissions globally. However, among transportation sources, the aviation industry is responsible for 12% of carbon dioxide emissions. Compared to the 74% of transportation CO2 emissions by road transport vehicles, 12% may seem small. However, it is significant, and with a projected compound annual growth rate of 7 to 14%, it could go even higher. China's electric plasma jet engine. A team of scientists from the Institute of Technical Science in Wuhan University have announced and demonstrated that they have created a potential energy source that could replace fossil fuels in jet engines. This energy source is air and electricity. Zhao Tang, a professor at Wuhan University and leader of the team, says that the motivation of our work is to help solve the global warming problems owing to humans' use of fossil fuel combustion engines to power machinery, such as cars and airplanes. Describing the design, he added that there is no need for fossil fuel with our design, and therefore there is no carbon emission to cause greenhouse effects and global warming. The demonstration involved the use of electricity and microwaves to induce a pressurized airstream into producing an impressive amount of thrust. The prototype thruster was able to lift a steel ball weighing 1 kilogram over a quartz tube with a diameter of 24 millimeters. When scaled up to the size of a working jet engine, this plasma engine prototype is able to provide the same thrust needed to propel a jet or plane. According to Tang, our results demonstrated that such a jet engine based on microwave air plasma can be a potentially viable alternative to the conventional fossil fuel jet engine. Therefore, in theory, constructing a jet engine with an array of plasma prototype thrusters while providing it with a constant stream of air and high-power microwave sources would be able to replace conventional fossil fuel engines and subsequently eliminate 2% of global CO2 emissions. This ability to scale the prototype thruster to an actual plane-size engine is what the team of scientists are currently working on. NASA Dawn space probe's ion thruster. Now, some of you might feel the need to mouth off in the comment section about how plasma engines kinda already exist. The other kind of engine that's similar to the plasma is the ion thruster. The NASA Dawn space probe moves in space by making use of a gas like xenon gas. The ion thruster shoots out positive ions of the gas to propel the probe. An ion is either positively or negatively charged, depending on if the atom has lost or gained an electron respectively. The ion thruster has an ionization chamber where the ionization of the xenon gas occurs. It does this by bombarding the gas with electrons inside the electron chamber. The resulting positive ions, or cations, are attracted to negatively charged ions. Therefore, in order to prevent the cations from reacting with the electrons that are inside the ionization chamber, a stream of electrons are being emitted on the outside of the thruster. This way, when the positive xenon ions are shot out of the ion thruster, they react with the electrons and get neutralized instead of getting reintroduced into the ionization chamber. Limitations to the ion thruster. However, the ion thruster faces one major setback in terms of transportation, and that setback is the existence of forces in Earth's atmosphere. In space, the NASA Dawn space probe is effective for space travel because there are zero forces opposing the motion of objects. In fact, in space, you could propel yourself by bouncing off a surface with something as tiny as a strand of hair. However, the plasma thruster proves to have the potential to surmount these atmospheric forces to enable the plane to fly vertically in Earth's atmosphere. And one thing that differentiates the plasma thruster from the NASA Dawn space probe ion thruster is the fact that it makes use of plasma, rather than a special gas like xenon gas. What is plasma? So, what is plasma? Well, plasma is the fourth state of matter. That's right, alongside liquid, solid, and gaseous states. If you're just learning this, you'll be even more surprised to learn that plasma is also the most abundant state of matter in the observable universe, and it has special characteristics like being able to conduct electricity and glowing up as well. One important feature of matter is the ability to move from one state to another. This is called phase change. With this, we have been able to create plasma by providing gases with enough energy so that it gets ionized. In nature, This energy can be provided via high temperatures like the sun, or through electrical fields like lightning. In essence, lightning ionizes the air around it, turning it into plasma. Then the plasma, in turn, allows the smooth flow of the electrical current through it. Plasma in the prototype engine. However, the plasma prototype developed by the team does not use a large amount of heat or a powerful electrical field to convert the stream of air to plasma. Instead, it makes use of high concentrations of microwaves from the microwave generator to convert the air to plasma. There is an electrical spark in the inlet of the tube that heats the plasma in the quartz tube, creating concentration of hot plasma and consequently high pressure that will generate the much-needed propulsion in future planes. This propulsion has an amount of thrust that is comparable to a combustion jet engine per square meter. Can the plasma engines scale to larger jets? They were recorded to have produced 11 newtons of thrust in a 400-watt microwave jet prototype engine, while about 4 newtons of that was from the pressure of the compressed air alone. This means that the prototype generates around 28 newtons per kilowatt. However, the figure can easily be higher or lower based on the flow rate of the compressed air, as well as the amount of microwave energy being used. This is the current challenge with scaling the prototype onto jet engines of a conventional plane, for example. Civilization-changing technology. So, there you have it. The aviation industry is one of the most important means of transportation today, and it'll definitely become even more important as we move into the future. If Zhao Tang and his extraordinary team of scientists are successful, or to be honest, if anyone is successful in perfecting the plasma jet engine to scale to large jet engines, then we could be looking at a cleaner and safer future for the rest of humanity. Scratch that. The future would be safer for all life on the planet, and maybe even in the universe. Thankfully, the fuel needed for this new engine is the most abundant fuel that we could ever dream of, and most importantly, to the best of our understanding, it leaves no harmful residue or byproduct as well. This is a technology that's been waiting in the wings. However, it's looking very likely to fly, and maybe it'll take us into the future with it. But what do you think? Is the plasma jet engine a waste of time? What other technology do you think can replace fossil fuel engines? Let us know in the comments below. And if you enjoyed this video, make sure to give it a like, and check out more awesome ones on the Simply Tech channel. Thanks for watching, and we'll see you next time.